Dark matter. It's a phrase that sounds like something from science fiction, yet it is one of the greatest unsolved mysteries of modern science. Despite being invisible, untouchable, and almost entirely elusive, dark matter is believed to make up about 27% of the universe. To put that in perspective, everything we see, stars, planets, galaxies, and even ourselves, accounts for just about 5% of the cosmos. The rest? Well, most of it is dark matter, along with a mysterious force called dark energy. So, what exactly is dark matter, and how do we know it exists if we've never seen it? Let's unravel this cosmic enigma. What is dark matter? To understand dark matter, we first need to define what it isn't. Dark matter is not the same as regular matter, the stuff that makes up atoms and molecules. It doesn't emit light, doesn't absorb it, and doesn't interact with electromagnetic forces. This is why we can't see it or detect it directly. But that doesn't mean it's not there. Scientists infer the existence of dark matter through its gravitational effects. In the 1930s, Swiss astronomer Fritz Zwicky first noticed something strange when observing a distant galaxy cluster. The galaxies were moving too fast, as if some unseen mass was holding them together. Years later, Vera Rubin's groundbreaking work on galaxy rotation curves confirmed this anomaly. Stars on the outer edges of galaxies were moving just as fast as those near the center, a phenomenon that should be impossible if only visible matter were present. The only explanation? There had to be some invisible mass, dark matter, exerting gravitational pull. How do we know dark matter exists? There are several key pieces of evidence pointing to the existence of dark matter. 1. Galaxy rotation curves. As mentioned, galaxies spin too fast for the amount of visible matter they contain. Without dark matter, galaxies would fly apart. 2. Gravitational lensing. When light from distant objects bends around massive objects like galaxy clusters, it creates a phenomenon known as gravitational lensing. The amount of bending often indicates more mass than we can see, suggesting the presence of dark matter. 3. Cosmic microwave background radiation, CMB. The CMB is the afterglow of the Big Bang, and its tiny fluctuations provide a map of the early universe. These fluctuations reveal the influence of dark matter on the formation of galaxies. 4. Large-scale structure of the universe. The way galaxies are distributed throughout the universe suggests they are influenced by dark matter, acting like a cosmic web that connects and shapes galaxy formation. What could dark matter be? This is where things get speculative and exciting. Scientists have proposed several candidates for what dark matter might be. 1. WIMPs, weakly interacting massive particles. These hypothetical particles could be heavy and slow-moving, interacting only via gravity and the weak nuclear force. Despite numerous experiments, WIMPs remain elusive. 2. Axions. Another candidate. Axions are extremely light particles that could form a vast, invisible field throughout the universe. 3. Machos, massive compact halo objects. These include black holes, neutron stars, or other compact objects that don't emit light. However, they cannot account for all the missing mass. 4. Sterile neutrinos. A heavier version of the neutrinos we know. Sterile neutrinos could account for dark matter if they exist. Despite these theories, dark matter has not yet been directly detected. Scientists have built massive underground detectors, launched space telescopes, and even used particle accelerators like the Large Hadron Collider. But so far, the mystery remains unsolved. What if we're wrong? There's a possibility that dark matter doesn't exist at all, or at least not in the way we think. Some physicists propose that we may need to modify our understanding of gravity itself. The theory of modified Newtonian dynamics suggests that the laws of gravity behave differently on cosmic scales. While intriguing, modified Newtonian dynamics has struggled to explain all the evidence that supports dark matter. Why does dark matter matter? You might wonder, why spend so much time and effort on something we can't even see? Understanding dark matter is crucial because it shapes the universe. Without it, galaxies wouldn't form the way they do, and the universe as we know it wouldn't exist. Unlocking the mystery of dark matter could also lead to new physics, uncovering forces or particles that fundamentally change our understanding of the cosmos. The quest continues. For now, dark matter remains one of the most profound mysteries in science. It is a reminder of how much we still don't know about the universe, but it's also a testament to human curiosity and determination. Scientists continue to push the boundaries, searching the cosmos for answers to questions we once thought unanswerable. Perhaps the answer to dark matter lies just around the corner. Or maybe it's something so revolutionary that it will upend everything we think we know. Either way, the journey to solve this cosmic puzzle is as fascinating as the mystery itself. Watch more content in science, philosophy, and psychology on Knowledge tab. Stay curious. Stay inspired.